Now let's do one more example where we put all of the decision rules together. So consider an investment for a project that will cost us $100,000 and then provide a cash inflow of $25,000 every year for 5 years. If the required return is 9% and the required payback is 4 years for both our payback and our discounted payback rule, we want to look at each of the decision rules and decide whether we take the project on all of them. So here we have a pretty nice and easy set of cash flows because all of the cash flows are the same. So we have a lot of repetition. We have 5 years of cash flows for this project and then it finishes. So in the initial year, their initial cost, $100,000. And then 5 years of $25,000 per year. And then the project ends. So we want to know what the payback period is, and then the discounted payback, the net present value, internal rate of return. At each step we decide, do we take the project? Of course we want to know what the primary decision rule would be, and that one's easy. It's always the net present value rule. When is the internal rate of return rule unreliable? Well, there's 2 cases when it's unreliable. We have the case of mutually exclusive projects and the case of non-normal cash flows. Neither of that goes on here. So the internal rate of return should agree with the net present value rule and be just as reliable. And then finally we want to solve for the profitability index, which is our final rule. So we start with the payback rule, and the payback rule just says how long does it take before the positive cash flows equal the negative cost. And because our cash flows are so easy, this one should be obvious. Right? We have $100,000 in cost. Right? This is our CF0. And then we have $25,000 in cash flow every year. So hopefully you see that it's going to take us 4 years exactly to pay back this project, as we add $25,000 in cash flow every year. So after the first year, I will still have to pay back $75,000. After the second year, I'll still have to pay back $50,000. After the third year, I'll still need to pay back $25,000. And in the fourth year, my cash flow will exactly equal what I need to pay back. And so it will take me 4 full years exactly to pay back. And my payback rule is that I should take any project that pays back within the time period, within 4 years. And so I accept this project because 4 is within 4. Now, my discounted payback is the exact same thing, only on a discounted basis, meaning I need to take the present value of the future cash flows and then see if the project pays back on a present value basis. Now, because we only just accepted it on a payback basis, hopefully it's clear that we won't accept it on a discounted basis, because a discounted cash flow, a present value, is always lower than a future value. And so 4 years of lower discounted cash flows cannot possibly get us to accept within a 4-year period if I only just got there on a future value basis. And we can see that here. I need to take the present value of the cash flows, and here the future value of the cash flows is always $25,000. The discount rate is always my required rate of return, and that's 9% per year. When I'm taking the present value of these 5 cash flows, the only thing that changes in this problem is my n. I need to take 5 different present values at an n of 1 year, 2 year, 3 year, 4 year, and 5 years. And then I compute my present values. And if I do that, I'll get a present value of my first cash flow equal to $22,935. a present value of my second cash flow equal to $21,042, a present value of my third cash flow equal to $19,305, a present value of my fourth cash flow equal to $17,710, and my final year 5 cash flow will have a present value of $16,249. Now we know we're going to reject this project based on a present value basis, on a discounted basis, because these 4 cash flows can't possibly equal $100,000. But we still want to see what the discounted payback period itself is. Remember, there's always 2 parts to each problem. So we do the same thing. We start with our initial cost of $100,000. I add my year 1 present value cash flow of $22,935. And I see that I still have to pay back $77,065. So I add my year 2 cash flow present value, $21,042. And I see that I still have to pay back $56,023. So I add my year 3 cash flow present value, $19,305. And I see that I still have to pay back $36,718. And if it wasn't clear before, now's where you'll see that we won't pay back on a discounted basis, because the present value of my year 4 cash flow is only $17,710, which means in year 5 I still have to pay back $19,008. But my payback period rule is 4 years, so already I need to reject. But I want to know how long it'll take. So I add the present value of my year 5 cash flow, $16,249. And I see something else unusual, which is that my project only has 5 years of cash flows, and on a present value basis, I never generate enough cash flow to cover my initial cost. And so the answer here is that I reject, because I don't cover it in 4 years, but I reject because this project never pays back on a discounted basis. In fact, if you'll remember the discussion from the earlier discounted cash flow problem, or the discounted payback problem, you'll remember that what we've done here is essentially calculate the net present value of this project. We added the present value of the future cash flows, all 5 of them, subtracted the initial cost, and we get a negative NPV. So in this case, the NPV rule and the discounted cash flow rule, or the discounted payback rule, are going to give us the same answer. We're going to reject this project. It never pays back on a discounted basis, and it's going to have a negative net present value. And we'll be able to see that when we solve for net present value, which is the next question. We'll use the calculator to solve for net present value. So we'll go into our cash flow environment. We'll clear the values with second and clear work. We'll enter in our initial cash flow, which is our initial cost, $100,000. That cost needs to be made a negative. And then I set that value with the enter button and move on with the down arrow. I can enter in my first cash flow, $25,000. That's a cash inflow, so we leave it as a positive value. We set that value with the enter button and move on with the down arrow. Now here we can again take advantage of the frequency button, because this cash flow repeats 5 times. And we can save ourselves from having to enter in $25,000 for each of the following 5 cash flows. And if I set that value with the enter button, I'm finished entering my cash flows. I can solve for net present value by pressing the NPV button, entering the required rate of return as the discount rate. And then computing my net present value. And as we saw in the previous page, I get negative $2,758.71. Slightly different because of rounding, but again, we now have our first case of negative NPV, and we reject this project because the NPV is less than 0. And this should be more or less our default assumption about most projects. Most projects aren't good ones. Most businesses fail. Net present value being less than 0 is not an unusual thing here. So we reject the project on an NPV basis. We should also reject on an IRR basis. And as long as we haven't done anything, we can simply press the IRR button and press compute and see that the internal rate of return is equal to 7.9308%. And we reject the IRR based on the IRR rule because the IRR is less, 7.93 is less than the required return, which is 9%. Now we can do both of those on the calculator so that we can see something specific here with the calculator. So we'll go back into our cash flow environment and clear our work. We'll start with an initial cost of $100,000. We make that a negative. We move on to C01, which is our initial cash flow of $25,000, and we set that value with the enter button. I change my frequency here to 5 because that cash flow repeats 5 times. And while I'm done here, I do want to point out that when you're using this calculator, the unfortunate thing is that if I were to say go on, so C01, I'm now telling the calculator that the next 5 cash flows would be $25,000. If I had a 6th cash flow that was different in this problem, and I wanted to go and enter that 6th cash flow, I might expect that the next thing I'll see is C06. But unfortunately, the calculator doesn't do that. It leaves it as C02. And that's nothing you would be doing wrong here. It's just a quirky function in the calculator. It doesn't update the number, even though I wish it would. We don't have a 6th cash flow though. We just have 5 $25,000 cash flows. We want to solve for net present value. We press the NPV button. We enter a 9% discount rate. We compute our net present value, and we get negative $27.58. We want to solve for IRR. We just press IRR and then compute, and we get 7.9308. Now the last thing we want to do is we've answered the intermediate questions. Should we accept the project? No, we reject. The golden and silver rules tell us to reject, so we don't take this project. So we'll skip 5, 6, and 7 and jump straight to 8. 8 is, what's the profitability index? And the profitability index is a ratio, and it's a ratio that uses the same information as the net present value. The profitability index is the present value of the future cash flows, or the sum of the present value of the future cash flows, divided by the cost, whereas the net present value is the sum of the present value of the future cash flows minus the cost. And so there's a couple ways we can figure this out. In the first, we can remember that NPV is the sum of the present values of the future cash flows minus the cost. And we already know the net present value. And we already know the cost. What we don't know is what the sum of the present values of the future cash flows is. And so with a little bit of algebra, we can solve for that. We can solve for the sum of the present value of the future cash flows to be 97,241.2816. And then we can solve for the profitability index, or the PI, by dividing 97,241.2816 by the cost of the project, which is 100,000. And we get 0.97241. And the way we interpret the profitability index is How much do we make for every dollar that we invest? And again, we see that this is a project that's going to be a bad one for us, because this says we make $97 for every dollar that we invest, every dollar of cost. 97 cents for every dollar means we're losing 3 cents for every dollar we invest. And so we should reject this project. Now, there's a trick to solving for the present value of the future cash flows that we haven't used yet, but you can take advantage of if you're only doing a problem that requires the profitability index, and so you don't already know the net present value. And you can do the trick in the cash flow environment itself. And what you do is you enter in all the cash flows exactly the same, except for set the initial cash flow equal to 0. So pretend that there's no initial cost. Then enter $25,000 a year for 5 years and compute the net present value using the appropriate discount rate. So I'll just come here and I'll recompute, and I'll compute the net present value, and I'll get the present value of the cash flows, because the calculator just tries to add up the present value of the future cash flows and subtract whatever number you put in as cost. But because we put in a 0, it doesn't subtract anything. So I can use this trick if I need to solve for the present values of the cash flows directly.